Welcome to the world of sliding bearing and tribology.
このスライドは日本語で書かれていますが、自動音声のナレーションは英語です。それぞれのスライドに記載されている説明の主要な部分を英語のナレーションでお聞きいただけます。
What is tribology? It is origin of the mechanism analysis of bearings. It is an academic term based on the etymology of tribo, which means of friction in Greek, and it becomes friction studies if translated literally. This term began to be used in England in the mid-1960s and is defined two sliding surfaces that interfere with each other while doing relative motion and related problems and practical applications. Although there is little essential difference from the academic field such as conventional friction and lubrication, it is an academic discipline and technology on friction and lubrication according to economy that emphasizes the relation with economy and business management strongly.
Bearing element technology performing stabilization of rotating machineries. The bearings used in turbomachinery are mainly rolling elements, such as ball bearings, and sliding bearings that are also called metal, which are important components of rotor dynamics that determine the performance stability of turbomachinery. Sliding bearings are available in a variety of bearing journal shapes and mechanisms. To meet needs for rotor dynamics as load capacity, rotor speed, stiffness, damping and stability. The purpose of this course is to understand the mechanism of sliding bearings so that you can maximize the performance of your sliding bearings and drive safely and comfortably by understanding the structure, mechanism, function, and design elements of sliding bearings with various characteristics. The wheel is the invention that has caused the greatest technological innovation since the history of BC. This is a stone wheel made in 3400 BC, but improvements have been made since then, and thrust bearings and journal bearings were used for wooden wheels made in Mesopotamia 4518 years ago. Oil the bearing and turn lightly. You know that when you think that the pedal of the bicycle has become heavy, if you oil the rotating part, it will slide better and turn lightly. When sliding bearings were first developed, it was understood by the simple theory that bearings reduce friction and turn lightly when oil is made. Experiment of bearings for railway vehicles by Mr. Towers. A phenomenon discovered by British scientist Beauchamp Tower in 1883, which conducted the refueling of lubricants, used for bearings for rail cars and the fruit of performance confirmation, was that pressure was generated in the oil film of the sliding bearing. Mechanism of sliding bearings. Let's consider the image of the bearing that supports the rotating shaft by replacing it with the wheel of the car. Driving when the road surface is wet requires more attention to slip accidents than dry surfaces if the amount of rain that can be puddled on the road surface increases the risk of aquaplaning phenomenon in high-speed driving. Think of this aquaplaning state as the operating state of the sliding bearing. Wet surfaces of load replaced to cylindrical bush bearings. Wet surfaces road are bearings that support the shaft of rotation. The wheel of an automobile is a rotating shaft that rotates in the bearing. Oil is poured into the road surface to reduce the frictional resistance of the shaft rotation. High-speed operation causes aquaplaning phenomenon, creating an operation state in which a rotating shaft floats on the oil film. This condition is the operating state of the sliding bearing by oil film lubrication. Wedge-shaped oil film formed to generate hydraulic pressure. The bearing gap is about 1.5 to 2.5 of the shaft diameter, and the viscosity of the oil drags the oil in the axial rotation direction, but due to the narrowing of the gap-reduced height, a part of the oil must flow from the bearing end with axial flow velocity, and the viscosity resistance causes pressure P in the oil film. This hydrodynamic oil film pressure becomes an oil film reaction force facing the load, pushing the shaft and the bearing apart to maintain the oil film shape, and the axis rotates floating on the oil. The eccentric angle is the direction in which the oil film thickness is minimized at an angle measured from the static load line gravity direction in the direction in which the axis eccentricity is eccentric from the bearing center. Bearing effective area and load. Specific pressure calculated by total load per effective surface area. PV pressure velocity. Value shows effective range of bearing rotation. The idea of floating bearing loads, a rotating shaft floating on the film of oil that separates the surface of the bearing and eliminates wear, came from an experiment conducted by the Beauchamp Tower in the UK, and the results of the experiment were published in 1883 and 1884. Osborne Reynolds, who saw the results of this experiment, thought that if the oil film was thick enough, the hydrodynamic equation could be inferred, and the 1886 Reynolds wedge oil film paper was completed. In 1889, with Professor Thurston of Cornell University, Albert Kingsbury found that if the bearings were geometrically identical in shape and in the same lubricating oil refueling conditions, the impact on friction was the same, even if the bearing surface material was made of different metals. He published a paper in 1897 that made air-lubricated bearings and determined the air film pressure, in addition to measuring the pressure of the air-tapered film that actually supports the weight of the rotating journal. He later invented a segment-shaped thrust bearing tested between 1898 and 1899 at the University of New Hampshire, creating Kingsbury's innovative thrust bearings. On the other side of the world, Australian inventor A.G.M. Michel patented it in 1905 for inventing tilting pad thrust bearings very similar to Kingsbury's idea. Tribology research has evolved into further study of Reynolds, who demonstrated Tower's theory, and then Sommerfeld reaches a nearly complete level of fluid lubrication theory. Both the founders of Mitchell Bearings in the UK and the founders of Kingsbury Bearings in the USA invented tilting pad bearings around the same time. Performance required for bearing surface metal materials. Anti-fatigue. Performance to withstand load and load fluctuations. High melting point. Ability to withstand bearing high temperature. Anti-pressure. Bearing performance of a variety of bearing load and pressures. Corrosion resistance. Performance to withstand the influence of oil and atmosphere. Flexibility. Ability to absorb misalignment. Embeddability. Ability to embed foreign material, debris and contamination. Non-burnable. Performance to prevent seizure in boundary lubrication conditions. Comparison table of characteristic elements of anti-friction rolling bearings and sliding bearings. Basic structure of sliding bearing materials and metal. As the surface material of the sliding bearing, metal materials of iron-based materials such as cast iron, copper alloy, aluminum alloy, tin and lead alloy, ceramic materials, and resin materials are used. In combination with these materials, bearing composite materials that combine the characteristics of each material are also used. Metal made of a single material with a bearing structure is called single-layer metal, but in single-layer metal, it is possible to achieve both flexibility and strength with one type of material, so the materials and applications are limited. To solve this problem, two types of materials applied as strengthened by backing matter and flexible surface material, called two-layer metal. Further overlaid added two-layer metals on top called three-layer metal is used. Tilting pad bearings have a structure in which the pads can be tilted and wedge-shaped oil film is easy to form. The point at which the pad will tilt is called pivot. The difference in pivot position is the center pivot and the offset pivot, but the offset pivot pad has approximately 1.4 times the load carrying capacity of a center pivot pad with the same surface area. Therefore, for machines with one-way rotation, of course, the offset pivot pad is a more safety factor bearing. Machines with both directional rotation use the center pivot pad method. There are two types of tilting pad bearings, thrust bearings that support axial thrust loads, and journal bearings that are sustaining radial loads in the right angles to the shaft axis. There is also a combined bearing that combines thrust and journal. Various shapes besides tilting pad bearings. There is a sliding bearing with features. The simplest journal bearing is a hole in the frame. I rotated it through the shaft there. Fixed profile journal bearings. Journal bearings whose journal arc shape does not change for bearings that tilt and move the pad like tilting bearings are called fixed profile journal bearing, and the following bearing is used by the arc shape of the inner diameter of the journal. Cylindrical journal bearings. Elliptical or lemon bore bearings. Offset half bearing. Multi-arc bearings, 3-lobe bearings and 4-lobe bearings. Plain journal bearings. Plain cylinder, also called cylindrical bushing, is the most basic journal bearing, and it is made of various bearing materials depending on the application and operating conditions such as oil-containing metal and bushing, but the bearings covered in this course are specialized in sliding bearings using white metal babbitt, so that it is easy to assemble on the axis. It is divided into two halves as top and bottom, and the two-part bush of the structure which arranges the refueling hole and the oil groove in the upper and lower matching surface, and supplies lubricating oil from the circumferential groove provided on the outer peripheral surface to the refueling hole is often used. Elliptical lemon bore bearings. This is a journal bearing that improved the function of the plain journal bearing by the deformation of the bidivision journal bush bearing. The bi-split bearing machining method is to cut the cylindrical material with babbitt centrifugal cast top and bottom, process the matching surfaces of each halves, combine them, and apply hole machining of the journal diameter. If you pinch the shim of the thickness necessary for the seam and process it round, a bearing that has an oval shape like a lemon will be completed. The journal metal inner diameter with a large curvature with respect to the shaft diameter further adds the preload effect, thereby increasing the stability of the bearing. Offset half bearing. It is a journal bearing that improved the function of the cylindrical bearing by the deformation of the bidivision journal bush bearing, and is a bearing processed into a shape in which the center of the top and bottom metal inner diameters is offset. The outer diameter is round, but the inner diameter is shifted by the top and bottom halves and the y-axis is combined. Since the inner diameter shape is not a round but a step, the direction of rotation is one-way rotation. It has excellent vibration control and is an effective bearing shape for preventing self-excitation vibration and oil whirl. Multi-lobe bearings, 3-lobe, 4-lobe. 3 types of bearings, perfect axis, lemon bore, and offset half, are suitable journal bearings for most applications, but in consideration of further special functionality, bearings with shapes called 3-lobe and 4-lobe are also manufactured. Multi-arc bearings are also more complex in machining methods and naturally cost more than the 3 major formats of journal bearings. We learned that there are various shapes in the arc shape of fixed profile journal bearings. Let's compare the characteristics in each shape bearing, including the characteristics of the tilting pad bearing. Comparison table of arc shape and bearing characteristics. Plain. Low speed. Not suitable for light load. Ellipse. Lemon bore. Improved speed. Vertical stiffness weak. Offset half. Improved stability. One-way rotation. 3-lobe. 4-lobe. High speed and light loads. Tilting pad type. Good high speed. Good stability. Thank you for your attention. We will finish the slide bearing course of Chapter 1. Please look forward to the next course. Please look at the blog page of the author's Hobby Bonsai and Goldfish. See you soon.